So we can generate volumes by not just by rotating things, but by taking some cross-sectional area that forms with part of the graph. In this case, we're going to do it with the x-axis. So let's take a look at an example here. So we're going to have a function. Okay, so I'm just going to lay it like this. So the function is going to be square root of 1 plus sine x. So it's going to be something that looks something like that. Okay, so I think it's going to look something like that. And we're going to take the area between 0 and pi. So pi is going to be somewhere around here. So this area in here is going to represent the base of a solid object. Okay, and that section there, that area, we're going to take the perpendicular distance from the x-axis. So this perpendicular distance here, which is essentially the f of x, okay, or the y value. And we're going to take a square and take it out of the plane. Okay, so imagine this is a plane. I should just maybe change that a little bit. Okay, so imagine this being a square coming out of the plane, and we're going to take that square area and we're going to have every section here be represented by a square area. So it's going to form a three-dimensional solid by doing that. Now this square area, we need to be able to, and if we're going to calculate volume, we're going to take this area and we're going to give it some thickness. Okay, so we're going to give it some thickness. We're going to call that dx. Okay, so there's our thickness dx. And all those sections then are going to be, we're going to have different size squares all the way from the y-axis all the way to that endpoint line there, which is pi. And we're going to add up all those these square rectangular blocks and calculate the volume of that object. So first of all, you got to try to imagine what that looks like. So there's a visual that will help you take a look at that. But this is what we're going to do. So we're going to take basically the height of this graph, which is our y value. We're going to create a square area and give that square area some thickness. So it's going to look like this. So I'm going to take the f of x. Actually, maybe I'll do this in green. And I'm going to take that f of x value. So the distance here is f of x. Okay, so that's going to be the length of that edge. And take that f of x and I'm going to square it. Okay, so I'm going to get that square area. Now I need to give that square area some thickness. Okay, I'm just going to change the color of this. So that thickness I'm going to call dx. Okay, so I'm going to multiply that by the thickness dx. That's going to give me each of these pieces, and what I want to do to find the volume of that solid then is I need to integrate that. And I'm going to do from x equals 0 to x equals pi, and that will, if I add up all those rectangular blocks, okay, that's going to give me the volume of that solid. Okay, so what does that look like when I put it all in? So I'm going to integrate from 0 to pi. My f of x function is going to be square root 1 plus sine x, and I'm going to square that and multiply that by dx. Okay, so there it is. So conveniently, the square and the square root cancel out, they undo each other. So we're going to end up with from 0 to pi. Okay, this is going to be 1 plus sine x dx. Well, that's a fairly easy integral to work out. Okay, so the volume then works out to be x plus cos x, or sorry, minus cos x, and I'm going to integrate that from 0 to pi, and that will give me the volume of that three-dimensional solid that I'm going to generate here. Okay, so that solid is going to be pi minus cosine of pi is -1, okay, and then minus 0 minus cosine 0 is 1. Okay, so that's going to be pi plus 1 plus 1, so pi plus 2 units cubed is going to be my the volume of that solid. Okay, so if you want to visualize that, there's a video after this that will show you the visual of what that three-dimensional solid is going to look like. Okay, so this next one here, we're going to generate the base of this solid with the function e to the x. So if I draw e to the x function, it's going to look something like this. Okay, so there's my y-axis, here's my x-axis, and x is 0 to 2. Let's say 2 is right about there. Okay, and so what we're going to do is take this area, and this represents the base of the solid. But this time now, we're going to take the perpendicular cross section to the x-axis. So it's going to be this perpendicular line from the x-axis to f of x. And we're going to take that length and we're going to make a rectangle coming out of the plane. And the rectangle is twice as high as it is wide. So the width here is f of x, and it's going to be twice as high. So it's going to be a really tall rectangle that looks like that. Okay, so there's my f of x. The height of this is going to be double f of x. So f of x times 2. Okay, that will give us the height of that rectangle. Okay, so f of x gives us the width there. This is the area, the cross-sectional area that we want. Now we need to integrate this. We need to get volume, so we're going to give this cross-sectional area some thickness. We'll call that thickness, that is going to be a dx thickness. Okay, so that piece there is going to be, we're going to take a whole bunch of those pieces, really thin ones though, and we're going to add them up from 0 to 2, and then we're going to get our volume in that way. Okay, so how do I set this up again? Okay, so I need to get my cross-sectional area first, so it's going to be f of x is my length times 2f of x is my height. Okay, so that's going to be length times height. And then we have to take this area and we're going to have to give it some thickness to get some volume. Okay, so I'm going to multiply that by dx and then integrate from 0 to 2, and that will give us a volume. Okay, that was going to give us a volume of that three-dimensional shape. Okay, so it's kind of hard to see what that shape's going to look like, but as we go this way, it's going to get taller and taller. Okay, as we go to the left, we're going to get shorter and shorter rectangles. Okay, so there it is. There's our integral. So we're going to calculate the volume. Okay, so we're going to go v equals, the f of x function is e to the x. Okay, so I'm going to write this in as from 0 to 2. The width was e to the x. The height is 2e to the x, and then we're going to multiply that by thickness dx. Okay, and then sum up all those parts, and that's going to give us our volume. Okay, so this volume then, the integral actually works out to be fairly easy. It's going to be 2e to the x times e to the x, so e to the 2x. Okay, and then integrating that, it just becomes 2e to the 2x over 2, and we're going to go from 0 to 2. Okay, so then plugging in, the 2's cancel out, so it's e to the 4 minus e to the 0, which is 1. There's our volume in units cubed. Okay, so then it's kind of hard to visualize, but make sure you understand how to set this up. We're going to need to cross this distance here. It's going to be represented by f of x. And the height of this rectangle is going to be double that, so 2f of x. So here shown up as e to the x times 2e to the x. And then we give it some thickness and we integrate it.